This is Diganta from Fractions Up. We'll be doing a pretty popular problem today, and we'll be using some basic tricks from number theory in order to solve this. But this is a good problem per se, since it introduces binomial coefficients and box functions pretty well. And this is asked in the objective exam sometimes, right? So let's go ahead. The problem goes as follows. Show that box of 2 plus root 3 whole power n is odd for every positive integer n. Now, the interesting thing in this problem is that this is pretty easy if you see two simple observations. And remember, we'll be going to use these two things. So let's proceed. Observations. One, you see that 2 minus root 3, the conjugate of this, is greater than 0 and less than 1. So this would be pretty handy. Why, you will see? Because this is some value between 0 and 1. So the box of this is 0. So the floor of this is 0. And the roof of this, the roof of this is 1. Right? So we go to the next observation. What happens when we sum this up? That is 2 plus root 3 whole to the power of n plus 2 minus root 3 whole power n. So we just expand this out. So this comes out to be summation I running from 0 to n into I to the power of n minus I root 3 whole to the power of I plus summation I running from 0 to n minus 1 whole to the power of I into I to the power of n minus I root 3 whole to the power of n. Right? Now, observe that these things would cancel out. Some of these would cancel out, and the remaining would be there twice. Once in the left hand side, once in the right hand side. So this simplified gives us the following, right? Action j running 0 to box of n by 2 and choose 2j. 2 because we want to remove root 3, right? So the power of n minus 2j times 3 to the power of 6. So we have removed root 3 and we see that the following: 2 plus root 3 whole power n plus 2 minus root 3 whole power n is equal to twice of sum j running from 0 to box of n by 2 and choose 2j 2 to the power of n minus 2j times 3 to the power of j. So 2 plus root 3 whole power n this equals what? Choose 2j, 2j, j minus 2 minus root 3 whole power n. Remember that this is something between 0 and 1. So raising this to the power of n keeps it between 0 and 1. Right? So this is the even number. This is something between 0 and 1. So we want the box of this. So essentially, box of 2 plus root 3 whole power n. This is the box of twice of summation j running from 0 to box of n by 2. And choose 2j to the power of n minus 2j, 3 to the power j minus 2 by root 3 whole power n. So an even number minus some fraction between 0 and 1. So we are done, right? Implies this is odd always. An even number minus something. So we take the box, we get the odd number just below that. So this was the problem for today. This was a pretty easy but pretty interesting problem for those of you who haven't seen it. Thank you.